So in this session we are going to start the exercise 20.3 which involves the integration of trigonometric functions. Alright, before starting this topic, as I told you in the beginning that I will share the strategy to find out the integration of any function without learning its working formula, right? And with the same strategy, with the same working, I am going to teach you how to integrate any trigonometric function. The basic identities we have is the integral of cos x is sin x, integral of sin x it's minus cos x, and integral of sec square x equals to tan x. These are the reversals of what we had learned in the differentiation. If the derivative of sine is cos, that means the integral of cos it's sine, as these are two reversal functions. Alright, so on your screen there are some examples of how to integrate the functions. The first one is quite simple, that find the integral of 1 plus cos x. So firstly I will expand the brackets here. So integral times 1, it's integral dx plus integral of cos x dx. So integral of dx it's x plus the integral of cos x it's sin x, and since it is an indefinite integral, so you need to highlight C here as well. So that is the answer of your first example, number 14. Alright, it's quite simple. Expand the bracket, find out the integral of these two functions, and the working formula we have right here. Now in my next example we need to integrate 3 cos 2x plus 1 dx. Now listen to me very carefully, because that thing is quite important right now. The integral of cos is sine, we know it very well. Again, in this identity we know that the integral of cos it's sine, but the question arises when the integral of cos it's sine. So the answer is when the derivative of the angle is right with next to it. Alright, when the derivative of the angle is written next to the function, then you can integrate the function of cos. Now that principle we have learned in the previous exercises, that to find out the integral of any function, make sure the differentiated part must be written with next to it, so you can derivate the function. Now the derivative of angle 2x plus 1, if we derivate it, so its derivative will be 2. So that means we need 2 here, which is currently not present. So what we are going to do, it will be 3 as act as a coefficient, so I will write outside the integral sign 3 cos 2x plus 1 dx, that is a function, and we are going to multiply and divide it by 2, because now the derivative of angle is written just next to it. So now the function is ready to derivate, and this 2 we can bring it outside right here. So I can write in this form cos 2x plus 1 times 2 dx, and now my function is ready to integrate. So it will be 3 upon 2. The integral of cos 2x plus 1 it's sine 2x plus 1 plus c. So that is your answer. Alright, so I hope that you got the idea that how to integrate the trigonometric function. And the next thing, a very important thing, whenever you are solving trigonometric parts in calculus, your calculator must be in radian mode. The same thing we have discussed in the differentiation. So make sure when you are doing integration or differentiation or their applications, your calculator must be in radian mode. Now we have discussed about the example. Now we are going to continue from book questions. So it's exercise 20.3 and it's question number 1. integrate with respect to x. That means we are going to integrate all of the functions, and we are going to start from one part b. So part b, it says 1 minus 3 cos x. So first of all, what you need to do, write down these three working formulas so you can easily attempt all the questions, and you have a time of 40 seconds to note it down. So start. Alright, now I hope that all of you have written the working formula, so now you can integrate the functions easily. Integrate with respect to x, that means we need to integrate this function. So it is quite same that what we had done in the example. So give it a try first, and time for this part is 50 seconds. So start. Alright, so firstly you need to expand the brackets here. So it's integral of dx minus 3 integral of cos x dx. Currently there is no number with the angle, so the derivative of x is 1, so it is already present here, so we can easily integrate the function. So integral of x dx is x minus 3 integral of cos, it's sine x and plus c. That is your answer. Alright, I hope that you're getting the same value. And after part b, heading towards part d. Part d, integral of sec square x minus 4 sine x. So firstly we need to expand the brackets here. So integral of sec square x dx minus 4 integral of sine x dx. So the integral of sec square x, it's tan x, minus integral of sine x, it's minus cos x and plus c. So now the final answer is tan x plus 4 cos x plus c. Alright, write down the solution in your copy, and for this part time is 30 seconds. So start. Alright, so after part D, moving towards part F here, B, D, and then F. So for part F, it's 4 cos x plus 3 sec square x. Alright, so you have a time of 60 seconds. Give it a try. Start. Alright, so you need to integrate the function 4 cos x plus 3 sec square x dx. Alright, the integral of cos x, it's sin x, plus integral of sec square x, it's tan x, and plus c, that is your answer. Alright, now in all those questions, keep in mind that the angle is only x, so the derivative of x is 1, and that is why we are not multiplying with any constant here, which we had discussed in example number 16 in the above part. Alright, so I hope that all of you are clear with those easy parts in which we need to integrate the functions. Moving towards question number 2. Alright, so it's question number 2. Integrate with respect to x, and the part we are going to attempt here, it's b, d, h, L, and N. Alright, these are the parts we are going to attempt. So starting with the part B here, it says sine 3x. We need to integrate sine 3x. We know that the integral of sine is cos, but the question arises when the angle differentiated form must be written with it. That means to integrate sine 3x dx, we need to multiply and divide with the angle, and that is 3 divided by 3. Alright, and the benefit of 3 is this function which I have highlighted is now ready to integrate. The integral of sine 3x, it's cos 3x divided by 3 and plus c for indefinite integrals. That is your answer. Alright, and one thing, the integral of sine is minus cos. I have highlighted negative with the red pen because mostly students make a mistake in the sign. So that is the answer. After that, part D, it's cos 1 over 2x. The integral of cos is sine, but when we have the derivative of the angle. Alright, so 1 upon 2x, if you derivate the function, you will get 1 upon 2. Alright, so I need 1 upon 2 here. So what I will do, I need to integrate cos 1 over 2x dx. I need 1 upon 2 here, so I will multiply and divide 2 upon 2. Alright, the 2 in the numerator, I will take it outside the integral sign, so it's 2 integral cos 1 over 2x, and this 2 remains here, it's 1 over 2 and dx. Now the function is ready to integrate because the derivative part of the angle is written just next to it. So the integral of cos 1 upon 2x, it's sine 1 over 2x, and it's plus c. Alright, so I hope that you have an idea how to solve this type of questions. And moving on to the next part, it's part H. It says that 2 cos 1 minus x. So what you need to do, you need to write down these two parts in your copy and start the next one. And for these 3 parts, you have a time of 90 seconds. So start. Alright, so the derivative integral of 2 cos 1 minus x will be, the integral of cos is sine, but what is the derivative of angle? So if it's 2 cos, ready to integrate 1 minus x. Now the 1 minus x part, if you derivate it, that gives you the answer -1. Alright, so it's 2 cos 1 minus x dx, and we need -1 here, so it's -1 over -1. Right, now this function is ready to integrate because the derivative part is just right next to it, and this negative sign I'm taking common here, taking outside the integral sign, so it's -2 sine 1 minus x plus c. Alright, after part H, moving on to the next one. JK is part L here. So L is 3 sine 2 minus x, and you need to give it a try first. Time for this part is 50 seconds, so start. Alright, the integral of sine, it's minus cos when you have the derivative of the angle. So it will be 3 sine 2 minus x dx. The derivative of angle is -1. We need to multiply and divide it by -1. Similarly, the function is ready to integrate now. So it's 3. This negative sign I'm taking outside the integral. The derivative integral of sine 2 minus x will be minus cos 2 minus x and plus c. And if you simplify, it's 3 cos 2 minus x plus c. That is your answer. And after the part L, moving on towards the next part, it's part N, and it says 4 sine x minus pi over 4. Alright, so we know that the integral of sine, it's minus cos, and when you talk about the angle, so the derivative of angle is 1 because dy dx of x is 1, pi over 4 is constant, so that will be 0. So that is quite simple. It will be minus 4 cos x minus pi over 4 plus c. Alright, so that is the answer. And moving on towards the next question. It's question number 3. Now, in question number 3, we are talking about definite integrals because the sign of limit you can see present to the question. And in question number 3, the parts we are going to attempt, it's B, D, F, H, and B, D, F, H, and I. These are the parts we are going to attempt here. Alright. Alright. So let's start with part B. We need to integral from 0 to pi over 2, and the function we have, it's sine x dx, right? Now, the integral of sine is quite simple because the angle derivative is also 1, which is not a complicated case. So we know that the integral of sine x is minus cos x, right? But this time we are not going to introduce positive c here because we have limits, and the limits we have, it's 0 to pi over 2. Make sure that before solving this question, your calculators must be in radian mode. Alright, so we know very well that how to apply the limits here. So it's minus cos, upper limit it's pi over 2, minus cos, lower limit it's 0. Alright, now cos pi by 2 is basically cos 90, and cos 90 is 0. So that will be minus 0 minus minus plus cos 0, it's 1. The final answer is 1. Alright, so I hope that it is clear to you. Moving on to the next part, you just need to focus on the solution, no need to write it down, I will give you the time for that. So for part D, it says from 0 to pi over 4, it's sec square dx, right? The integral of sec square is 10x, right? So the integral of sec square x, it's very simple, it's 10x, right? And the limits we have, it's from 0 to pi over 4. We know very well how to apply limits here. So it's 10, upper limit is pi over 4 minus 10, lower limit is 0. So 10 pi over 4 is 1 minus 10, 0, it's 0. The final answer is 1 here. Alright, and the next part we have, it's part F. The question says integral from 0 to pi over 6 3 cos x minus 2 and dx. So what I will do first, I will expand the brackets here. So it will be 3 integral from 0 to pi over 6 cos x dx minus 2 integral of 0 to pi over 6 and it's dx, right? Or you can say 1 times dx, it's same. So now when you integrate cos x, so that will be equals to sine x, and we have the limits from 0 to pi over 6 minus 2. The integral of dx, or you can say 1 times dx, it is equals to x, and the limits we have it 0 to pi over 6. Alright, now applying limits here, so it's sine, upper limit it's pi over 6 minus sine, lower limit is 0 minus 2, upper limit is pi over 6 and lower limit is 0. Alright, we have placed the limits value in the variable x here. And now sine pi over 6 is basically sine 30, and sine 30 it's 1 over 2. You can find out the value of sine pi over 6 in radian mode from your calculator. So 1 upon 2 minus 0 minus 2 times of pi over 6. So now it will be 1 over 2 minus 2 1s are 2, 2 3s are 6 minus pi over 3. If you take LCM here, it will be 6, 2 3s are 6, 3 2s are 6. Alright, and there's 3 outside the integration, so we need to carry out that 3 here. So 3 is basically outside the bracket, and if you simplify, it's 3 1s are 3, 3 2s are 6. So the final answer is 3 over 2 minus 2, 3 minus 2 over 3. 3 minus 2 pi over 2. Alright, and this 3 is only multiplied with the first part, so it will be multiplied with this one. Alright, so that will be 3 over 2 minus pi over 3, and that is your final answer. Alright, so I hope that all of you clear in these 3 parts, and now you need to note down the solutions in your copy, and for these 3 parts you have a time of 2 minutes to write down the solution, and then we are going to start the next part, so begin. Alright, so after part D, moving towards part F. Now listen carefully, because no, this will be also seen in part H and part I. There is a little bit change, but part F is almost similar. It's from 0 to pi over 6 3 cos x minus 2 times dx integrated. So it's 3 integral from 0 to pi over 6 cos x minus 2 0 to pi over 6 dx, right? So it will be 3 integral of cos, it's sine x, and limits we have from 0 to pi over 6 minus 2 integral is x 0 to pi over 6. Alright, so it will be 3, applying limits here, so it's sine pi over 6 minus sine 0 minus 2 pi over 6 minus 0. So now it will be 3 sine pi over 6, it's sine 30, that is 1 upon 2, minus it will be 2 times pi over 6, so it's 3 upon 2 minus pi upon 3, which I did again this part. So moving on towards the next part, it's part H here. Alright, so in H part it's from minus pi over 3 to pi over 6. We have the value of limits, it's cos 3x dx. Now in this part the function is not ready to integrate because the angle is 3x, right? So what you need to do, you need to multiply and divide it by 3. Now the function derivative part is present next to it, so you can now derivate it, and this 3 in the denominator I will take it outside the integral side. So it's 1 upon 3, right? The integral of cos 3x, it will be sine 3x, applying limits here, so it's minus pi over 3 and the upper limit is pi over 6. So now it will be 1 over 3 sine 3, upper limit is pi over 6 minus sine 3, and lower limit is minus pi over 3. So 3 1s are 3, 3 2s are 6, 3 and 3 cancel. So it's 1 over 3 sine pi minus sine minus pi. Alright, so we can easily calculate it. So sine pi is negative 0.0004 minus sine of negative pi, it's 0.0004. So these two values cancel. Alright, but here I forget it's pi over 2, right? So it's sine pi over 2. So the value of sine pi over 2, that will be 0.5 minus 3.142 with a negative sign, and sine is 0.0004. Alright, so it will be the value of sine pi by 2, it's 1. Alright, so 1 minus 0.004, that will be approximately 1. So 1 upon 3 times 1, it will be 1 upon 3, and that is your final answer. Alright, so heading towards the next part, but before that, as we had already done part F, I'm just going to do this one. And after part H, we are going to start the last part. It's part HL. It says from 0 to pi over 8 sec square 2x dx, right? So firstly, we know that the integral of sec square is 10x, but if it's sec square 2x, so firstly we need to multiply and divide it by 2. The derivative of the angle is now written with next to it, so now the function is ready to integrate. And sec squared 2x, it will be tan 2x, alright. Limits from 0 to pi by 8, and that denominator 2, it's 1 upon 2 outside the integral part. Applying limits, so it's 1 upon 2, upper limit it's 10, 2 times pi by 8, 2 times of pi over 8 minus 10, 2 times of 0, alright. So 2 ones are 2, 2 fours are 8, so it's 1 upon 2, 10 pi over 4 minus 10, 2 times 0 is 0, and lastly it's 1 upon 2, 10 pi over 4, it will be 1 minus 10, 0, it's 0, so 1 upon 2 times 1, it's 1 upon 2, alright. So that is your answer, and this part is not L, it's part I. So you can write down the solution of H and I in your copy, and for this two parts you have a time of 90 seconds to note it down in your copy, so start. Alright, so moving on towards the next part. It's question number 4 from the same exercise. It says evaluate from 0 to pi by 4, and you have 1 plus tan square x dx. So the first step is integral from 0 to pi over 4, it's 1 times dx plus 0 to pi over 4. In fact, no, because we are going to stuck when we are at this point, right? So this method is not right because we are going to stuck at this part. We don't have the integral of tan square x, right? So what is the correct approach to start this question? Integral from 0 to pi over 4, 1 plus tan square x dx. Now let me recall you the identities we have learned in trigonometry. You all know that sine square x plus cos square x equals to 1. Similarly, we know that 1 plus tan square x equals to sec square x, right? So we are going to use that identity here. So it's the integral of 1 plus tan square x, it is equals to 0 to pi over 4, 1 plus tan square x is sec square x dx. Alright, and now we know that the integral of sec square x, it's tan x, the limits we have it's 0 to pi by 4. If you apply the upper limit, it's tan pi over 4 minus tan 0. Tan pi over 4, it's 1 minus 0, it leads to 1. Alright, so that is your answer, and you can note down the solution, and you have a time of 40 seconds to note it down, so start. Alright, so I hope that it is clear to you that how to integrate the functions, how to apply identities in trigonometry, and how to integrate the trigonometric functions, right? So I think that is enough for today's class, and as a homework, what you need to do, you need to attempt question number 3, part k of the same exercise which we had done today. So see you in next class. I hope that all of you have submitted your homework on time. So see you in next class. Take care and Allah Hafiz.